Hello viewers, in today's class we are going to solve one problem based on the concept of independent events in probability. So the problem is a person A speaks truth in 60% cases while the person B in 90% cases. Now in what percent of cases are they likely to contradict each other in stating the same fact, right? So here we have two persons, and this person A, he speaks truth in 60% cases, right? And the person B, he speaks truth in 90% cases. Now we have to find the probability that these two persons will contradict each other in stating the same fact, right? So let us start, but before solving this problem, let us first see the definition of independent events. Suppose we have two events, say E and F, right? Now these two events E and F are said to be independent events if the probability of happening of this event E does not affect the probability of happening of this event F, right? So then these two events are said to be independent events, and the condition for these two events to be independent events is given by the probability of E intersection F must be equal to the probability of E multiplied probability of F. So this is the condition for two events E and F to be independent events. So let us solve this problem. Now here we are given this information that A speaks truth in 60% cases and B speaks truth in 90% cases. So it means that A lie in 40% cases, right? 100 minus 60 is 40, and similarly B lie in 10% cases, right? So A speaks truth in 60% cases and A does not speak truth in 40% cases. Similarly, B speaks truth in 90% cases and B does not speak truth in 10% cases, right? So let us write these two informations in the form of probability notations, right? So if we denote A event A by saying that the person A speaks truth in 60% cases, then we can write PA is equal to 60 over 100, right? Similarly, the event B says that this person B speaks truth, right? So here we have 90 over 100, right? Now here we have this information that A does not speak truth in 40% cases, so we can denote these two informations or the events by the complement notation, right? By putting a bar over A and B. So we have P of A bar is 40 over 100 and P of B bar as 10 over 100. So this denotes the probability that A does not speak truth is 40 over 100, and here the probability that B does not speak truth is 10 over 100. Now we have to find the probability that these two persons A and B will contradict each other in stating the same fact, right? So let us see the conditions when these two people A and B will contradict each other, right? So we have two cases here. The first one is that A speaks truth, right? A speaks truth, but B does not speak truth, right? So here we say that B does not speak truth, right? Okay. Now the second case arises if A does not speak truth while B speaks truth, right? So these are the only two cases where these two persons A and B will contradict each other, right? So A will speak truth but B will not, right? And here A will not speak truth but B will speak the truth. Now these two conditions can be written as A and B bar, right? So A represents that A speaks truth, right? So this event A, and B bar represents the event that B does not speak truth. Similarly, this situation can be written as A bar and simply B. So A bar denotes that A does not speak truth, right? Now let us write this condition in terms of the probability notation. So here we have the condition that A will speak the truth but B will not. So this fact will be written as PA intersection B bar, right? And here we have the condition that A will not speak the truth but B will, right? So this can be written as the probability of A bar or A complement intersection B, right? So here we have to find these two probabilities, right? And we will add these two probabilities to get the probability of the persons A and B contradicting each other. So viewers, now we have to add these two probabilities, right? So the total probability, right? The total probability that these two people A and B will contradict each other, is the sum of these two probabilities, that is P A intersection B complement plus P A complement intersection B, right? So now we will calculate these two probabilities with the help of this formula, right? So when E and F are two events and they are independent, then the probability of intersection of E and F is the product of the individual probabilities, right? So here we have to see one important thing, that when A and B are independent, right? A and B are independent events, and if A and B are independent events, then A and B complement are also independent events. Similarly, A complement and B are also independent events. So we'll apply this rule in these two probabilities. So here we have PA multiplied P of B bar plus P of A complement multiplied probability of B, right? Now we'll substitute these values in this expression to get the required probability. So here we have PA is 60 over 100 multiplied 10 over 100 plus here we have 40 over 100 multiplied 90 over 100, right? Now this expression is equal to 600 plus this is 3600 over 10,000, and this is equal to 4200 over 10000, and 20 and 20 get cancelled, so we have here 42 over 100. So the probability that these two, A and B, will contradict each other in stating the same fact is 42 over 100, and in terms of percentage it is 42%, right? In 42% cases, A and B will contradict each other in stating the same fact. So viewers, this is how we solve this problem.